Exponents are useful in expressing very small or very large numbers. Explore the world of exponents in this video. So let us start defining what is an exponential notation. If a is any real number and n is a positive integer, then the nth power of a is. So you are given with this expression, a to the power of n is equal to a times a times a times a and so on until to the nth factors. Meaning, for example, when you have 2 to the power of 3, it means 2 times 2 times 2 times 2. So, that is equal to 8. And then, how did we do that? The number a is called the base and n is called the exponent. So the base, for example, in this example, 2 to the power of 3. The base is equal to 2. The exponent is equal to 3. So in this notation, the exponent tells us how many times we are going to use the base as a factor. So for example, 2 to the power of 3. We have exponent 3. So it tells us that we are going to use 2 as a factor 3 times. That's why we have 2 times 2 times 2. In evaluating exponential expressions or power expressions, we are going to use the laws of exponents. So, we have the following laws. Number 1, product of a power, power of a power, power of a product. So later on, it will make sense what are these laws of exponents. So the first 3 laws, we will apply this one if the operation being involved between the power expressions is multiplication. And then for quotient of a power, power of a quotient, this is very useful when we are dealing with division of power expression. We have another law of exponent, the zero exponent, and then the negative exponent. So we are going to discuss each law of exponent one by one on the following slides. First, we have product of a power. It says that for any numbers a and positive integers m and n. So in this case, a is our base, our integers are m and n, and it's specified positive, but this product of a power generally will apply to all kind of exponents, positive or negative exponent. So it says that if we have a to the power of m times a to the power of n, that is just equal to a raised to the power of m plus n. Observe that our operation is multiplication. Also note that we can only apply this law of exponent if we are dealing with power expression of the same bases. So you look at the bases of the power expressions. In this power expression, we have the base is a. On the next power expression, the base is also a. So we can just apply the product of a power if we are dealing with power expression of the same base. So what we are going to do, from multiplication, that's why it's called product, instead of multiplying, we are just going to copy the common base, which is a, and then just add the exponent. So you look at the pattern. If the operation between the power expression is multiplication, what you are going to do with the exponent is just add. So that's the pattern. Okay, example, 2 squared times 2 cubed is equal to. So you look at the given, we have the same base. Base is equal to 2. And then the operation is multiplication. So applying this law of exponent, what we're going to do is to copy the common base, which is 2. And then just add the exponent. So we will have 2 plus 3. And what is 2 plus 3? That is equal to 5. And 2 to the power of 5 is equal to 32. That's it. Next law. Power of a power. To raise a power to another power, multiply the exponents. So in If we have a to the power of m raised to the power of n, that is equal to a raised to the power of the product of m and n. So in this case, we already have a power expression, meaning we have a base and then an exponent. So what happened is we raised that one to another power. So what we're going to do to find the answer is just multiply the exponents. Okay, example, 2 squared raised to the power of 3. So you can see this is a power expression with the base 2, exponent is 2, and then it's being raised to another power which is 3. So applying power of a power law, we're just going to copy the base and of course multiply the exponents. 2 times 3. And what is 2 times 3? That is equal to 6. And 2 to the power of 6 is equal to 64. Okay, how did we get 64? Apply the exponential notation. If we have 2 to the power of 6, that is 2 times 2 times 2 times 2 times 2, and that is equal to 64. Next, the power of a product. To raise a product to a certain power, raise each factor to the indicated power. So for any numbers a and b and any integer m, ab raised to the power of m is equal to a to the power of m, b raised to the power of m. So observe that on the given, we have a product, the product of a and b. And then it is being raised to m. M is a power. So what we're going to do to solve this kind of problem is just raise each factor to the indicated power. Again, in our given, the factors that we have are a and b, meaning we're going to raise the power m to each of the product. That's why we have a to the power of m, b to the power of m. So you look at this as it is somewhat similar to the distributive property, but in this case we are distributing the exponent or the power to each of the factor. Okay, example, 2x squared raised to the power of 3. So if you are going to look at it carefully, we have the given inside the parentheses, it is a product of 2 and x squared. So how are we going to do this? Just distribute the power. So we have our factors 2 and x squared. So we are going to raise each factor to power 3. So you have 2 cubed times x squared to the power of 3. 2 cubed is equal to 8. X squared raised to the power of 3. Apply the power of a power. A power expression raised to another power. So just copy the base and then multiply the exponent. 2 times 3 is equal to 6. So we have 2x squared raised to the power of 3, that is equal to 8x to the power of 6. And that's it. Next, we have quotient of a power. From the term quotient, meaning the operation involved is division. When dividing powers with the same base, exponents are subtracted. So you can see the pattern. If we are dealing with multiplication, we are going to add the exponent. If it's division, then subtract the exponents. Okay, we have a to the power of m over a to the power of n. Again, observe that in order to apply these laws of exponent, the bases should be the same. If the bases are not the same, then we cannot apply these laws of exponent that we are talking about. So again, applying the law, we are just going to copy the base and then subtract the exponent m minus n. So that is quotient of a power. Example, 2 raised to the power of 5 over 2 to the power of 3. So it's very clear we are dividing powers. So what we are going to do, since the bases are the same, we just copy the base 2 and then subtract the exponents. 5 minus 3. And 5 minus 3 is equal to 2. And 2 squared is equal to 4. That's it. Very simple. Next, we have power of a quotient. It works similarly with power of a product, wherein we are just going to raise each factor. But in this case, because we have power of a quotient, we raise both the numerator and the denominator. So if we have a over b raised to the power of m, that is just equal to a to the power of m over b to the power of m. So observe what happened. We are just distributing the power to the numerator and then to the denominator, and that's the law. Example, I we have b should not be equal to 0. Again, this should be emphasized because if we are dealing with division, the denominator should not be equal to 0 because division by 0 is undefined. Okay, example, x over 2 raised to the power of 3. We have a fraction being raised to the power of 3. So to simplify this one, we are just going to raise both the numerator and the denominator to the power of 3. So that will become x to the power of 3 over 2 to the power of 3. And then simplify what can be simplified. We cannot simplify further x cubed, so we just copy x cubed. But 2 to the power of 3 is equal to 8 because that is 2 times 2 times 2. And that's it. Next, we have 0 exponent. Always remember this one. For any number x where x is not equal to 0, x to the power of 0 is equal to 1. Or in words, any number raised to 0 except 0 is equal to 1. Again, it's emphasized that x should not be equal to 0 because 0 to the power of 0 is undefined. Again, in mathematics. So example, no matter how complicated the expression inside the parentheses, as long as it is raised to 0, that is equal to 1. That's it. Very simple. Negative exponent. For any real numbers a and n, a should not be equal to 0. A to the power of negative n is equal to 1 over a to the power of n. So for this law, the purpose of this is, in mathematics, when we say simplified, there should be no negative exponent. So to get rid of negative exponent, we just transform negative exponent into this form. If we have a to the power of negative n, that is equal to 1 over a to the power of n. So it becomes the reciprocal of a to the power of n if it has a negative exponent. Example, 2 to the power of negative 3. Again, the exponent is negative. So to make it positive, we just do 1 over. And then instead of the negative exponent, that will become positive 2 to the power of 3. And then simplify further because we can simplify this further. That will be equal to 1/8 because 2 cubed is equal to 8. And that's it. On the following slides, I will present some power expressions wherein we are going to simplify. So when we say simplify, there should be no negative and 0 exponents. So that's it. So while doing this, you can pause the video and then you can solve ahead and check if you can get the correct answer. Okay? First one, p to the power of 21, q to the power of negative 15, r to the power of negative 3 raised to the power of 1/3. So in doing this, what we're going to do is to apply the laws of exponents because that's all what we have. So looking at the problem, you have several power expressions inside the parentheses, and then they are being raised to the power of 1/3. So if you are paying carefully earlier, then you know that what you're going to do is to to raise each factor to 1/3. So what will happen? We will have the first factor, which is p to the power of 21. We raise that one into 1/3. Similarly, the next factor, which is q to the power of negative 15, we also raise that to 1/3. And recall that if we raise each factor to 1/3, exponent to exponent, we are just going to multiply. Next factor, we have r to the power of negative 3. So we are going to raise that into 1/3. And then, recall that a power being raised to the power, we are just going to copy the base and multiply the exponent. So you will have p 21 times 1/3, that is just 21 times 1 divided by 3, which is equal to 7. And then for this one, we have q negative 15 divided by 3 is equal to negative 5. Again, multiplying any number by 1/3, that is just similar to dividing it by 3. And then for r is, we have negative 3 times 1/3, that is equal to negative 1. Again, I already emphasized earlier, when we say simplified, there should be negative exponents. Okay, so to do that, let us do the wise way. Always remember this one. If the negative exponent is on the numerator, just bring that one or transfer that on the denominator and it will become positive. If the negative exponent is on the denominator, just move it to the numerator to make it positive. So in this case, since these exponents or power expressions have negative exponents, we just transfer these factors or power expressions at the denominator to make it positive. Okay, so to illustrate, we have p to the power of 7, then q to the power of 5. Because the exponent is negative, to make it positive, we just transfer it to the denominator. And then similar with r to the power of negative 1, that will become r to the power of 1. And again, we don't need to write exponent 1. And that's it. Magic rectangle. The second one, negative 10 z squared y to the power of negative 4 raised to the power of 2. And the quantity of z cubed y raised to the power of negative 5. So upon looking at the problem, we have a product of negative 10 z squared and y negative 4 being raised to the power of 2. So on this part, we already know that what we are going to do is to distribute the power, raise each factor to 2. So first factor is negative 10, so that is negative 10 raised to the power of 2. Next factor, we have z squared raised to the power of 2. Next factor is y to the power of negative 4. So we are also going to raise that to 2. So we are done with the first part. On the second part, the same. We have product of factors z cubed and y being raised to the power of negative 5. So we raise each factor to negative 5. First factor is z cubed. So z cubed raised to the power of negative 5. And then we have y to the power of negative 5. And then simplify each power expression being raised to that power. Negative 10 squared, that is negative 10 times negative 10, and that is equal to 100. For this one, z squared raised to the power of 2. Again, power of a power, just multiply the exponent. 2 times 2 is 4. So we have z to the power of 4. How about this one? The same, a power raised to a power, multiply the exponent. So we have y, negative 4 times 2 is equal to negative 8. And then multiply the powers. So you have z to the power of negative 15, and then just copy y to the power of negative 5. Next step, you observe these two power expression and look at their bases. Their bases are the same, meaning we can apply the first law that we discussed, the product of a power, because the operation between these two is multiplication. So just copy 100, and then if we are multiplying power expression, we are just going to add the exponent. So that will be 4 plus negative 15. So copy the sign, 4 plus negative 15. And then after doing that, we also observe that these two power expression also have the same basis. So we can also add their exponents. So you will have y raised to the power of negative 8 plus negative 5. So just add the exponent because we are multiplying these power expressions of the same base. And what is 4 plus negative 15? That is equal to negative 11. So see, your knowledge about integers is really useful. And then negative 8 plus negative 5, since we are adding similar signs, we can add their absolute value. 8 plus 5 is 13, and then copy the common sign, which is negative. That's why it's negative 13, and then we move it to the left. Now observe that we still have negative exponents. So the shortcut that I told you earlier, just transfer these two power expressions to the denominator to make it positive. So we will have 100 over z to the power of 11 y to the power of 13. Instead of negative exponent, we transfer this into the denominator, making it positive, and that's it. Magic rectangle. Next example, 5 times the quantity of 2a raised to the power of negative 1, b to the power of 3 raised to the power of 0. How nice. All over 10 times c to the power of negative 5, d to the power of 6, e to the power of negative 8. So first, you look at the problem. We have 0 exponent, so I think it's simpler. Now observe that what is being raised to 0 is not the whole numerator. It is just this quantity. So meaning we are just going to copy 5 because it is not being raised to 0. Times any number or any expression raised to 0 is equal to 1. But we don't need to write 1 because 5 times 1 is just 5. So just 5 all over. On the denominator we have 10. Next is we have a negative exponent. Remember what I told you earlier. To make it positive, just transfer it to the numerator. So we have c to the power of 5. D to the power of 6 is having a positive exponent, so it will remain on the denominator. So you have d to the power of 6 on the denominator. And then moving on, e to the power of negative 8. It's a negative exponent, so to make it positive, just move it to the numerator to make it positive. So you have e to the power of 8. But it's not yet done because you look at 5 and 10. When we say simplified, the numerical expressions or the numerical coefficients should also be in its lowest term. So since 5 and 10 are divisible by 5, we divide both of them by 5. 5 divided by 5 is 1. Again, we don't need to write 1 because we have remaining factors, c to the power of 5 and e to the power of 8. And then on the denominator, 10 divided by 5 is equal to 2. Then copy d to the power of 6. And since we do not have negative exponents anymore, we also do not have power expressions of the same base, then we are done. That's it. Okay, lastly, we have this one. It looks like very complicated, but if you have just the strategy together with the laws of exponents, it will be so very easy. So of course, when you look at this, we have power expressions inside, and then you look at 3 and 9. we can simplify this one, right? Before we are going to apply the power, so that we are not making the problems more complicated. We simplify first what is inside the parentheses, and then you raise it to the power of negative 2. So 3 over 9, that is divisible, or that can be simplified into 1/3. Both are divisible by 3. And then you look at the next factor, x to the power of negative 4 on the numerator and x squared on the denominator. They have the same base, so we can apply the quotient of a power. We copy the base and then subtract the exponent. So when we say subtract, that is numerator subtracted by the denominator, the exponent. So you will have negative 4 minus 2. And then moving on, again, they have the same bases, y. So we can do the same with what we did with x. So you will have y raised to the power of negative 5 minus negative 8. The same with z, that is negative 2 minus negative 9. And do not forget, we are still going to raise it to the power of negative 2. Okay, let us simplify what's inside the parentheses. Recall that 1/3 can be changed into 3 to the power of negative 1, right? So I have a purpose why I did this one. So you will see it later. 3 to the power of negative 1. Next, negative 4 minus 2 is just the same as negative 4 plus negative 2. So that is negative 6. Moving on, negative 5 minus negative 8, that is negative 5 plus positive 8. Negative 5 plus 8 is positive 3. Next, we have negative 2 minus negative 9, that is negative 2 plus positive 9. That is equal to z to the power of 7. And then raise that to the power of negative 2. Now, since what we have inside the parentheses is already simplified, we can distribute the power to each of the factor. So we will have 3. Negative 2 times negative 1 is positive 2. Next, negative 2 times negative 6 is positive 12. And then negative 2 times 3 is negative 6. Negative 2 times 7 is negative 14. Now, if you look at our answer, we still have negative exponents, and then this 3 squared can also be simplified. 3 squared is equal to 9. And then since this power expression has a positive exponent, it will remain on the numerator. And then these two have negative exponents, so we transfer this on the denominator. And that's it. Again, in simplifying power expressions, you can do it by your own strategy as long as you are applying the laws of exponents. And guys, always remember, no matter how difficult the problem you are facing with, always remember that God loves you.